Question 13. The volume of ammonia produced against time is measured in two experiments, and this is a Haber process. Enthalpy is given is negative 92 kJ per mole. In the experiment 1, 3 moles of hydrogen and 1 mole of nitrogen reacts at 45 degrees C. Pressure is 200. And the graph is shown here, right, for experiment 1. Experiment 2 then perform. And this experiment 2 differ from experiment 1 in one condition only. So now, how does the experiment 2 differ from experiment 1? Okay, choose the best answer here. So let's start with A. The iron catalyst is present in experiment 2. So obviously this is not really the answer. We know that catalysts can promote the reaction, make it faster, but it will not really change the composition. So from this experiment 1 and 2, we know that the amount of the products, ammonia, is different. So therefore, A is not really a suitable answer, okay, because the amount is different now. For the B, 2 moles of helium gas is present in the reaction mixture in experiment 2. Many of you might confuse when the extra gas added, pressure change and so on. But you all need to understand the helium is actually the gas that not really in this equilibrium. So means the presence of this inert gas or this the gas that is not really in this Haber process, it will not really affect this yield, right? So how many mole it put is actually will not really affect the concentration of the nitrogens and the hydrogens and the products. So therefore, it's actually no much effects on the reaction, right? So therefore, it's not going to suit this graph. Because experiment 2, there is a change. Means the experiment 2 rate is faster and the yield is actually lesser. That's the difference. Now, for the part C, this one, this answer C, a pressure of 250 is used. For this experiment 1 is 200. And the higher pressure now used for this Haber process. Okay, we know that left hand side is 4 mole, right hand side is 2 mole. When higher pressure used, so equilibrium will shift to the one that lesser mole, means it will produce lesser mole. Means it actually will increase the volume of ammonia. Okay, means the yield. Therefore, it's also not suit this graph because experiment 2 is actually form lesser. So the best answer and the only answer, of course, is D. Temperature of 600, which is higher than experiment 1. Experiment 1 is just 45 degrees C. So 600 degrees C is higher temperature. It will increase the rate. That's why we see this one, experiment 2, is happen faster than the experiment 1. Okay, because the temperature is higher. Okay, it's actually steeper, yeah. Okay, when you compare these two, and for the temperature also there will be one effect because this reaction is exothermic. So when temperature increase, the equilibrium try to reduce the temperature. So how to reduce the temperature? Because forward is exo, right? Means backwards reaction must be endo. So therefore the equilibrium will shift to left hand side to reduce the temperature. So therefore what we expect is the ammonia, which is the product now, it will be lesser. Because when temperature increase, the equilibrium shift to left hand side, so the product is lesser, which is should the this graph, because experiment 2 is a lower volume of this ammonia, right? So therefore answer is D. Okay, that's all. Thank you.